So tell me when to hit the start button.
Go.
Go. Here we go. All right. Daniel's not going to talk because he's thinking now he better have a fast computer for this demo. I'm assuming he's got some souped up stuff driving the auto
I'm running
segmentation
Windows
AI.
95 right now.
Oh man, I used to have Windows 95.
So I'm actually, yeah, I take the time to actually do the posterior area, flatten that, go next, done. Stop it. That's 35 seconds.
Stop. It's not. You're not done. What about the deprogrammer? Come on,
Oh,
bro.
I mean, you said splint. Oh, well, but here, let's do the deprogrammer real quick. So
Keep
I
it
will go.
going.
Yep.
So that was a splint in under a minute. Raul Bajer, Daniel Portal here. We are looking at a deprogrammer, a byte splint. Daniel, talk to us really quick about the finished result here, and then we'll get into the design and the design time. You said it's about 8 minutes, maybe plus or minus, depending on your speed. So if you have a seat of Exocad, you should be able to design this super quick.
Correct.
There's some AI tools that we're going to use as well. So maybe just walk us through some of the output here, and then we'll jump into the database and design away.
So this would be just let's call it a regular splint design in Exocad. We added some attachments here in order to make it into a deprogrammer. And I'm just going to show how the new AI tools will help us in the process of designing this type of device. Makes it very short and sweet. And yeah, that's
I
that's so
noticed the gingival margins kind of scalloped there,
yeah.
and
So all that is AI.
that's all AI from the tooth segmentation, right?
Correct. Correct. And
And
so
that's it only available in the latest release of Exocad, the AI
that is
segmentation.
correct. So all the AI tools that Exocad has released so far are available with the latest version of the software, 3.2 LFCNA. And that's kind of what I want to go over. The design time can be within 8 minutes. It's what I like to say. However, as I give the demo and explain some of the parameters and some of the things that the software is doing, it might take a little bit longer just because I'm taking the time to show all that. But yeah, it's definitely a fast.
All right, so Daniel, we want to do AI segmentation, but we were talking earlier that before you do that for the first time, you got to turn it on,
Yeah.
right? So where do we go to turn on AI segmentation to make sure that you have this powerful feature?
So all of the AI tools need to be enabled manually. At least that was my experience. It's very easy to do, but if you don't do it, then you're missing out. If you open your design software, go to Tools, go to Settings, and then you go here to the Cloud option. Make sure these are turned on. So here's your allow cloud-based multi-tool segmentation, crown generation, so that the software can
So by
suggest crown
default,
designs.
they're not turned on by default, so you have to
Right.
manually move those slider bars to enable that step.
That was my experience. Yes. And so, yeah, if these are turned off, you're not getting any of the AI tools in the software. So
Wonderful.
just double check if you haven't seen the software prompting you, hey, you want me to design this crown for you, or you want me to do two segmentation. If you're not seeing that, you just got to check that on, and then you'll be golden.
All right, let's jump in.
Okay. So first thing to do is just to set up your order form. Very simple. You select the entire arch as a byte splint. The antagonist doesn't have to be selected all the way like this. It can be as simple as that, and it'll work just the same. We'll save that, and then we'll jump into the design process. Now, just for demo purposes, I am using Exocad's demo byte splint case, just for ease, and so everybody has access to it. So this is what the software is going to do automatically is do this truth segmentation. It'll detect the teeth and it'll extract them. And it'll
So you're
create
not selecting them right now. It's just auto detecting your hands
hands
off.
off,
Show me your hands.
completely. Yeah, it's right here.
How
So
accurate? How accurate is this?
it depends on the quality of the scan. Just as anything else,
Uh,
if there's a lot of blurriness and you can't really see where the tooth ends and the tissue begins, then the software may have a little bit of problems. Doing corrections is very easy. You just go here, you kind of paint the area the software may have missed, and that's all there's to it.
so an
So
iOS scan probably segments a lot better than a impression, or about the same, or just depends.
whichever one is clear. So if you know how to take your impressions, it'll work just fine. If you know how to do your intraoral scanning, it'll do just fine as well. So
If you
That's
have an integral scan with color, like a PLY file, does that make any difference with the AI
no, sir.
segmentation or
No, sir.
no? No.
No, sir. No, it's based off of surfaces. So
How often are you using the AI segmentation? Like with all your case flow, is this a tool you use a lot?
yes, so for kits like this, even though I don't get asked to design splints very much, for everything that's aesthetic, so Smile Creator, it really becomes a very necessary tool for things such as photo alignment and photorealistic rendition, all these different tools that take your design to the next level, enabled by this tooth segmentation tool.
And I noticed the arrows off the teeth. That's the path of insertion for each of the teeth.
No, that's just
No.
the way the software detected teeth and how it extracted them, and so it's kind of pointing in the direction in which, let's say, the roots are created.
Huh.
So yeah,
So it
um,
doesn't that's not related to path of insertion at all
no,
right
sir,
there.
not at all. It's
Okay.
just what the software was able to detect in order to extract uh, the tooth shape, the tooth anatomy.
So then all we're really looking for here is a good gingival margin because that's where the border
Correct.
of the splint's going to go.
Correct. And if you see that it makes a mistake, again, you can go to correction and paint the area that it may have missed. And then the software will recalculate as that particular tooth to include whatever changes you've included for the next iteration. Okay. So
Perfect.
yeah, once that's done, and as you saw, the software did all that by itself, you would be able to click next. And then it takes you to this step, which here's where it's just going to take longer to design because I think there's a tool that's very important for us to go through. So the splint bottom determines your fit of the splint. So in this step, one, you're going to determine what the insertion direction is for the splint. So you can see all the undercuts and the facial aspect of the arch. So you can expose that as much as you want or as little as you want. You can create the undercuts that you think will work best. I personally like to get rid of as much undercut as possible. But as I do that, there's other parameters for me to consider. So for example, the offset. The software has a default offset of 0.03 millimeters, which is going to extrude the entire model by about that much. Okay,
Okay.
so it's going to make the model bigger by that distance. And so that gives you what some people call a fudge factor for your fitting. Okay, so trying to compensate a bit for manufacturing margin of error. The undercuts. Um, so if I apply this insertion direction and apply the parameters as I have them right here, the software is going to block out all the undercuts and we can see them here. However, no undercut on this surface now is deeper than this distance here, than the 0.1 millimeters. So from
What
these,
does that say? Allow undercuts to.
yeah, 0.1
Okay.
millimeters. So from the insertion direction, the undercut that is created, the software is going to block it out so that it's only 0.1 millimeters deep. And
So that
so,
would be the amount of retention that
correct.
remains. Got it.
Correct. And so that is, I believe, to be a very important tool to understand so that you can actually control what your retentions look like. On top of that, just really quickly, you can go into freeforming and you can actually freeform the blockout material, let's call it, and you can expose deeper undercuts if you wanted to by removing it.
So if you wanted to add retention to one specific area, you could.
Correct. Or you can
Wonderful.
block it out completely so you have no retention in that area.
In our 8-minute workflow that we're talking through, that'll take longer than 8 minutes. What's
Yes.
your default? Is it 0.1?
I if for the quickest uh, uh, um, result, and even just as a rule of thumb, always use Exocad's defaults and see what kind of results you get, and then you can tweak afterwards. Don't preemptively start changing parameters. Don't go asking your buddy, "Hey, what do you use?" That's useless. Just trust the software, trust the process. Start from a 0 point, which is everything that Exocad gives you, and then from there you start tweaking to, I guess, adjust to your particular setup. So I would change no parameters whatsoever here.
Do we
Okay,
need to
so
contemplate
go ahead.
milling or printing any drill offset? If you're people don't really mill splints these days. Some
Yep,
do,
that will be
but
done for you here. So when you're
okay.
setting up the order form, you can tell the software whether you're 3D printing or you're milling out of acrylic, and all that will be assumed. So in our particular case, I told the software that we're going to be milling this, and that's why here in the design process we have this milling diameter already being considered.
Sure.
And so all of anything that is narrower than 1.2 is going to get blocked out and compensated for.
Yeah, you're gonna have the milling offset basically to make room for the tool to remove material.
You can see it clearly here how the software expands my incisal edge
Yep.
a little bit more for that. So anyway, again, not 8 minutes, but just to be thorough, maybe at the end I could just run through the process real quick. So I'm going to go next. Software's going to ask if I want to use the articulator for demo purposes. We're going to skip that. You can see that the software itself drew the outline. It scalloped the outline of my splint, so it's already done for me. That is enabled because of the segmentation we did earlier. Okay.
All right, so Daniel, here's the proposed finish line. Are there some global tools to just move the finish line up or down?
Yes, sir. So there's margin detection parameters. You can expand that menu and you can determine whether you want to raise it by going into the negatives, for example, brought them up a little bit, or you could bring it down by going into the positive number and it drops it down towards the incisal edge. So that would be where to do that.
Yeah, so if you didn't want to touch the tissue at all, you could move it down, or if you wanted a little tissue engagement, you can move it up, and pretty easy to do there. Awesome.
Correct. And then, of course, you always have the option of just clicking and dragging the point where you want it and having the software recalculate your suggested changes.
Cool.
After that, some people like to click next at this point. I think it is important for you to consider the posterior area. So you can define the posterior area by a couple clicks, and you can have the software flatten the posterior area for you. It does it really quickly. Now, if you want the splint to be mostly flattened, then you can just tell the software your posterior area begins right there, and then the software will try to flatten as much as possible. So it's a cheap way.
Like the starting line of where to flatten it out.
And so you can have the software flatten more than it's supposed to just by what the actual definition of posterior area would be. So you can do that, and then the software gives you about that result. Okay. After that, you go to the next step. You'll have options to freeform your splint, so you can soften or you can add material. You can flatten areas, et cetera, et cetera. Usually at this point, there's very little you should be doing. And so you just take it to the next step, and the software adapts the tabular surface, and there's your splint. Now, let me run through that without saying a single word, so you guys can see how fast the design would be.
Hold on, before you do that, we're gonna do a stopwatch. All right, so
holding me to the fire. I love it.
Are we? So tell me when to hit the start button.
Go.
Here we go. All right. Daniel's not going to talk because he's thinking now he better have a fast computer for this demo. I'm assuming he's got some souped up stuff driving the auto.
I'm running Windows 95 right now.
Oh man, I used to have Windows 95.
So I'm actually, I take the time to actually do the posterior area, flatten that, go next, done. Stop it. That's 35 seconds.
Stop. It's not. You're not done. What about the deprogrammer? Come on, bro.
Well, I mean, you said splint. Oh, well, but here, let's do the deprogrammer real quick. So
keep it going. All right, so that was a splint in under a minute.
Yes.
That was a splint in under a minute. That's pretty respectable. AI segmentation, basically a shell flattening out the posterior, and you're done.
Yes.
So now for a deprogrammer, you're going to insert a shape. What shape are you using? A primary bar?
Primary bar extrusion. And then I'm going to make it a little bit wider and then very tall. Or, well, not that tall, but that tall. Right there. Just make sure that it's contacting your splint. Then you can add it. Then we can freeform it into shape so that it has no sharp edges. Then maybe add a little bit of extra material here for strength. And there's a deprogrammer. So now it's finished.
1 minute 56 seconds for a deprogrammed splint. Amazing. That's super interesting. Wow. Super easy. I mean, so all these AI tools, I used to work for a company that had an AI night guard. It was pretty awesome. I mean, a 35-second splint, I mean, that's about the amount of time it would take you to upload it and download it and all that kind of stuff. So, AI segmentation, you think that's what really help speed up the process?
Yeah, absolutely. Otherwise, I would have sat there scalloping the outline of my splint, and that would take at the very least another 1 or 2 minutes.
Yeah.
Uh, but because of the segmentation, the AI, the software does that for you and ready to go.
And then, so really, it's the segmentation, understanding your offset, your retention, like your path of insertion, and then the posterior plane, like smoothing that out, so to speak.
And granted, this is assuming that the default parameters the software gives you is going to give you a good result. Now, in my personal experience, that is very likely the case. You are going to get acceptable results using Exocad's default values. However, if you come to the point where you've decided, hey, I don't like this or that, you can make those changes into your order form once. Okay, so you can change all those parameters that may be affecting your fit, and then that's it. Now those become your new defaults. So now you can really just click next through the entire process, and that you're done.
So
And
if you get all
so
your settings and your defaults nailed down, you're going to be
done.
designing this in under a minute
Correct.
almost every time, unless there's something funky going on.
Yes. Now the other, and just to cover all my bases, so you should have access to different manufacturers with their preferred um,
Settings.
parameters, right? So you can go to say next dent, and so if I select next dent, when I click on the splint, it'll give me, well, of course, the one I pick doesn't have splint as an option, but it'll provide you with their
Minimum
specific
thickness.
materials,
Yep.
with their names, and
Let's pick
all.
a let's pick an Asiga printer with the key splint.
Okay, so we can say a SIGA, then I should be able to select your bisplint, and then you have here your dental guide or dental IBT or dental BT, sorry. And then all of these parameters are already set for you to
Nice.
optimize the design with their materials and their manufacturing process. So that will be the third option. So if the defaults don't give you, and you don't want to go through the learning curve of figuring out what your CAD/CAM system produces for you, then you can use their suggested values or parameters for their materials. And then you should be able to just click next, 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 and then you get through the design in about 30 seconds or so.
Amazing. If I know this is the splint design module, what's the minimum thickness we could we use this to design a retainer? Like
I mean,
how thin could you design a splint that's scalloped? Can you design it like 1 millimeter thick?
so, okay. So the quick answer is no, because the software enforces a certain thickness for the material that you're using. However, Exocad being a open, not, oh, gosh, it's not open source, it's open.
Expert mode, right? You gotta like do things.
Yeah, so I can customize the software and create my own custom material. We'll call it Daniel Splint or whatever you want to call it. And I can set all my minimum thicknesses and whatever other parameters I want. And then I can design off of that. Now there's and maybe I'm going to show my ignorance here, but there's a very, very thin line on what you can legally design on Exocad. If you start designing what's called medical devices, then
Totally.
I don't think the
Totally.
software has been FDA cleared for that, but that doesn't mean you can't do it. So
Yeah, and doctors have more freedom to go off label than labs and manufacturers do. You know, labs and
there you go.
manufacturers are required to follow QMS and 510K and all that. Doctors can, they can prescribe medication off label, right? And so
Oh, there
doctors
you go.
can do doctors can do unique things. But awesome, man.
Yeah.
Anything else you want to end with?
I mean, just as an extra, but the bisplint allows you to design those two things that I showed right now, just regular splint. A Deprogrammer can also help you design custom trays, which you may or may not find useful, but it could get you out of a pinch and as fast as it takes you to print it. So there's other applications for this bisplint specific.
Awesome.
Another option just came to me. You could do gingivectomy guides with
Ooh,
using this. So,
that's
but
for
again,
the window
yeah,
to do lasers to do crown lengthening, right?
correct. So you could create those using the bisplint with a couple of the workarounds. But again, we're now touching into the medical device, surgical guide type thing. So
Yep. Yep. I've been there.
Yeah.
I've been there in the world of what you should or shouldn't do according to
The
the
gray line.
IFU of the software. Yes. I mean,
So
needless to say, with expert mode, it sounds like you can do kind of anything you want, but you should be aware of what regulatory guidelines you have to follow.
yep.
Yeah, for sure. There's our disclaimer.
Yeah. Printed.
All right, Daniel. Thanks for the time. This was fun.
Yeah, man. Anytime.